Hello, Stats class. Here's lesson 10.2b, and I want to remind you that in 10.1a and also 10.2a, we started by knowing the population values, and then we found a probability about a sample. So we've done that twice now for proportions and means. And in 10.1b and 2b, so specifically 10.2b, which is now, we're going to take our sample values and use them to estimate a population value. So we're just going backwards, which is actually way more common, actually, that we would know the sample value. So in 10.1b, when we did this, it was with proportions, a difference of two proportions. With this 10.2b, we're doing a difference of two means. So we'll know x1 bar and x2 bar, which are the two sample means. We'll subtract them, and we'll use them to estimate our parameter, which is mu1 minus mu2. And we're going to do, as you probably could guess, the four-step test. But I'm going to talk about the details first before the example. So some picky details that change from what we have done before. And I'll do that first, and then I'll do the example of the four steps. So the normal condition changes a bit. And this part shouldn't surprise you. We've seen this change before when we went from one proportion to one mean. Now we're switching from two proportions to two means, and so we're going to go with the n has to be bigger than 30. But remember, there's two n's. There's an n1 and there's an n2. And this could be that we have big samples like this, or it could be that the populations are normal. Sometimes that's given to you. Or it could be that you have to check a graph. And there's two graphs to check now. So that's the 15-30 rule. We've seen all of that before. It's just now we have to do it with two different ones, and we're going to check them separately. We're going to check the first population could be any of these three, and the second population could be any of these three. It's okay, for instance, if one of them is greater than 30 and meets the condition that way, and the other one you have to graph. You do what you need to do for each sample separately. So that's the normal condition. We'll practice checking that in just a minute. The calculations have some changes, of course. So the formula for a confidence interval of two means is a lot like the formulas we've seen before. It starts off with our sample means being subtracted. Technically, that's our estimate, plus or minus. We're going to use T star instead of Z, which we've always done for means. T star, and hopefully somebody knows why. If we were in class, I would ask you why, and you would tell me. And then this is the S squared over N. It's kind of like the formula we saw in 10.2a with sigma, except it's S now because we don't know the population standard deviation usually. So when we're working with samples and trying to predict the population, we usually have to use S. That is why we are using T instead of Z. So that hopefully should not surprise you because you've seen that before too. Because we almost always, or usually, know S1 and S2, not sigma 1 and sigma 2. In other words, the fairy usually does not show up and help us out. And we are still doing what we've done before, which is to find T star by doing inverse T. That's the area under the curve, and GF, and the area is whatever percent plus half the extra that we've seen before. The problem is GF gets a whole lot harder in this chapter. So we've always done n minus 1 for GF. And this is the chapter where suddenly we can't do that anymore. Do you see why? So another sad face, because we have two samples now. Which n am I supposed to use? It's so confusing. So there's a couple of ways you can deal with that, and I'll show you both of them. Actually, I feel like I should probably draw a picture for this first and just remind you that we've got our C in the middle, which is our 95% or whatever, and then we have the extra little half of the piece right there. That's where this is coming from. Okay, so things we can do about this DF thing. There are two options. If you have a graphing calculator, I'm going to recommend you do option 2, but I'm going to tell you about option 1 first, because option 1 is what people did before graphing calculators existed. It's called the conservative approach. And it's called that because if in doubt, you go with the smaller sample and you use that. So what you do is you take the smaller one of N1 and N2, whichever one is smaller, and then you subtract 1 to get the DF. So that'd be kind of like what we've done before. On the AP test, the only time I would recommend you do this approach is if you're on a multiple choice problem, because sometimes they use that to get their multiple choice answers. So sometimes appears on AP multiple choice problems. On a free response, you really get a choice of which way you're going to do it. So you take the smaller one and you do N1 minus 1, or you do N2 minus 1, whichever one is smaller. And you use that for your DF. However, if you are using a graphing calculator, I recommend you do option 2, which is make the calculator do it for you. And it doesn't use this method. It uses a much more complicated formula, but it's slightly more accurate. I mean, the 95% thing is more accurate that way. So option 2 is technology. I actually searched online to try to find an online calculator that would do it with this method. I could not find it. Everything I did it the wrong way, which I'm going to tell you what the wrong way is in a little bit. But the calculator does it right. So if you have a graphing calculator, there's a calculator shortcut, of course, that uses a much longer and uglier formula. And I kind of hesitate to tell you that formula because I don't want you to feel like you should do it the long way. That longer formula, if you're totally curious, let me know and I'll show it to you. But basically what you would do is leave T star as a variable in your formula. Don't even fill it in. Plug in all the other numbers and let the calculator do the rest. And I would recommend you do that if you have a graphing calculator. If you don't have a graphing calculator, I recommend you do option 1 because I could not find any online things that did it correctly. And that's really sad. There are other methods out there that we're not using in AP Stats. So it's the 2 sample T-int. And I'm not going to write the formula that it uses. It uses this long formula. Okay. So we're going to use that in our example that I'm about to do here. Actually, I'll talk about both methods because some people might need to do it that way. So those are the picky details. Everything else is a lot like what we've done before. So it's mostly just those 2 changes and the fact that you have to deal with T star, which is a pain. So here's an example. Forestry this time. We are measuring the diameters of trees. In a state park, and we're wondering if it seems like the north side end of the park is different than the south end of the park, and we're trying to find an estimate of how different they are exactly. So we take a random sample of trees in the north, another in the south, and we're going to do a difference of I almost said proportions, difference of 2 means to see what the difference in diameters is. So I'm just going to start in on the 4 steps. I'm going to start with my state, and you guys should be getting so good at this. But remember, with confidence intervals, we only have to state the parameter and the confidence level. We don't have to write hypotheses. So I'm going to say I'm going to estimate the difference in means, difference in the mean diameters So I'm going to do mu north minus mu south with 95% confidence. And it just occurred to me that I didn't give you the actual data yet. So I could probably do that. I'm going to do that in a little box off to the side. I'm going to say we are given that the north, we have a sample size, I'm going to call it NN. Sample size for north is 30, and the mean for the north is 23.7 inches, and the standard deviation for the north. You really have to know all of this stuff in order to do this test. So I'm going to just give you the data, which would probably be in a paragraph if it was in the book. The sample size for the south is 40, and the mean for the south is 34.5. Oh, look, they're wider. That's nice. But are they, how much wider are they exactly? And this is supposed to say south, standard deviation for the south is 14.3 inches. Got it. That's the data that I forgot to give you before I started in on my state. Data. All right, step 2. We're going to plan. What we are learning how to do right now is a confidence interval. I'm going to just call it CI for a difference of two means. And the most important thing is interval, difference, and means. Those have to be in there somewhere. Random. Same conditions you already have this part memorized, I hope. I'm looking at it. Look, it says random right there. Yes, it's given. Sorry, that's a little messy. Yay, I'm so happy that that one's easy to check, aren't you? Normal. Okay, so now there's a couple different things we could do. We are not given the shape. We don't have enough information to make a graph. However, I'm very happy to see that 30 and 40 are big samples. They're big enough, at least. So I'm going to say yes, because both samples, and maybe in one of next week's lessons, I'll do one where we have to graph it. Not today. Both samples are greater than 30. So that's good. Independent. Remember, we talked about this with proportions. You have to check 3 things. You have to check, are they separate samples of the north and south? There's no way they could have not been separate. So yes, there are 2 separate samples independent of each other. And I'm going to say in a state park, it's pretty safe to assume that there's at least 300 trees and 400 trees in the 2 halves of it. So I'm going to say, and 30 is most likely less than 10% of all trees in the north half of the park, and 40 is less than 10% of all trees in the south. That's where we did this with lesson 10.1. Also, the independent step is a tiny bit harder now, unless it's an experiment, and then it suddenly gets easier because then you just say yes because it was randomly assigned. But this is not an experiment. This is a random sample situation. 3 things to check. All right, I'm going to slow down a bit on the do because it is a little complicated, but we can do this. I'm going to copy that formula from up above, but I'm going to put N's and S's on it, because if you can label them with something that helps you remember which is which, that is so much better. Plus or minus T star. The parentheses are optional. You can put them if you want to. And we have Sn squared over Nn plus S squared over Ns. So that's the 2 standard deviations for the north and the south, and then combined with the Pythagorean theorem, which is why we're squaring and adding them together. So then I'm going to start plugging in numbers. And I can't plug in T star unless I go find it later. So I'm going to actually do this with both options just so you can see what happens. I'm going to say for most people, I would think you'd be doing the calculator method. So I'm going to do that first. 34.5 plus or minus. I am not even going to try to find T star. I'm just going to write T star. That is perfectly acceptable because It's just the calculator's so much easier. T star, and then I need S, that's 17.5 squared over the sample size that goes with it, and then I need the other S, which is 14.3 squared over the sample size that goes with that. So I could calculate all of this with my calculator, and I could calculate all this. It's not super important that I do that because what I would rather do is pick up the calculator and do the shortcut. So let's talk about that shortcut. If you have a graphing calc, you will go to Stat Tests, and it is a 2-sample T interval. That's the one you want. It's number 0 right before letter A. Amazing. 2-sample T interval. Don't use the Z interval because that's if you know sigma, and we're never gonna know sigma. And if you have data in a list, you can choose that. Oh wait, I just did the wrong thing. Let's do it again. If you have data in a list, you can choose that and then give it your list 1 and list 2. We might do an example of that on a different day, but not today. Stats is what I have. I have these statistics, and I can, it looks like I already typed them in. Look at that. So there's my 3 numbers for each sample. Same data that I gave you a minute ago. Confidence level, make sure that's right. Do not choose pooled because it's a confidence interval, and also we'll talk about why you wouldn't choose pooled on the significance test. We'll talk about that on Monday. Don't choose pooled. I'm just going to tell you that. And say calculate. So I'm going to write down what I get, and then I'm going to show you a couple different approaches to getting the T star. Negative 18.64 and negative 2.956. In a minute, I will interpret this. But before I interpret this, I want to go off to the side and say DF. There's 2 ways to get DF. DF could be 30 minus 1, which is 29 if you're doing the conservative approach. If you do the conservative approach, then you have to type all of this. And that, I don't know, I personally would not choose that. Because if you do that, you'll get a different T star than what you get from the calculator. Notice the calculator actually did DF with the long ugly formula, 55.05. It comes out as a decimal, believe it or not, and that's crazy, from the calculator shortcut. So let's see how much of a difference that makes in our T star. I'm going to actually do T star both ways. So T star would be inverse T. By the way, inverse T is not on all calculators. It's only on the TI-84s, but you could go online and use the inverse T calculator that we found there. And you would put in the 0.975 because it's the 95 plus half the extra. And then you could either put in either of these depending on which approach you're doing. I will say be careful, and I'll tell you why in just a sec. So let me first do this. I'm going to just see what the difference is in my T's. If I do 29, I get a T star of 2.045. Or I could do T star inverse T of 0.975, and I'd plug in that weird DF value that the calculator found. And if I do that, 55.05, then I get 2.004. That's going to make a difference in my answer. So now here's the caution that I have for you. If you choose to do the calculator shortcut, then you should be using this one because that's what the calculator used. So what they would mark you down for, which I hope you won't do, is if you find T star by the conservative method and write it down, and then your answer comes from the shortcut, these would not match, and they would mark you down for that. So if you're going to put a number here, make sure it matches what you get here. So I'm just curious how much different that formula would come out to be. And I'm going to find out because I really want to know. You don't have to write this part down unless you want to. But 17.5 squared over 30 plus the 14.3 squared over 40. There's my, oops, yeah, I did a divide by 0 error. That's just really nice. Let's try to type 40 instead. My 4 button is sticky and it doesn't always work. There we go. Okay, so that's my standard error. If I multiply my standard error by the conservative t star, which is times 2.045, I get that for my margin of error. And then I would take my 23.7 minus my 34.5, and I would subtract that answer, and I would get a negative 18.8 instead of 6.4. So the conservative approach gives me negative 18.8. And then if I do it again with a plus, and then I wouldn't want that answer anymore, I'd want the original, then I would get negative 2.796. So it's not quite the same thing. This one leads to that one. This one leads to this one. It's so close that either answer counts as right on the AP test, but if this, whatever you write here doesn't match this, they will mark you down. And it's just crazy. So whichever one you choose, this is what I want to say, whichever you choose, stick with it. Because if you write down a T star, if you don't write down a T star, it's fine. I would say just don't write it down. It must match your answer, or else they'll mark you wrong. So that's my advice, is choose one method and stick with it, and don't write down what T star is unless you're sure that it's the same one that you used to get this. That's what I'm saying. All right, so we need to do step 4, and then we are done with this. So the step 4 is the conclude, of course. And remember, with confidence intervals, the conclusion looks like we are 95% confident. So now you could write something about which one is less, or you could just start by writing the sentence that you've memorized, which is fine. I'm going to say the interval from negative 18.64 to negative, it's both negative, so that means it is a significant difference, inches, contains the true difference in mean diameter. Of trees north minus south. In other words, we could even add something saying, in other words, the trees in the north have a smaller mean diameter. And it could be smaller by anywhere from 2.9 inches to 18.64 inches. We're not sure, it's somewhere in there. And that's how you do a confidence interval. Crazy. So to summarize, the most important piece here, or most important pieces, is you have some choices of how to find T star. If you have a graphing calculator, I recommend you do this, which is the longer formula. The shorter formula you would use only if you can't do the technology method, but whichever method you use, if you write it down, it needs to match your answer. And both answers are considered right as long as you're consistent, as long as you don't switch in the middle of the problem from doing one to the other, which I kind of just did, but I showed both, so it's fine. That's enough notes for today, don't you think? And we will do significance tests on Monday.